Our next demonstration will be given by Ms. Eva Gail Rising, founder and CEO, and Mr. Darian Rising, founder and CTO of United Aircraft Technologies. The topic of their presentation is Augmented Reality Monitoring System for Aircraft Wiring Maintenance. The company will have 20 minutes to demonstrate their technology, followed by a 10-minute Q&A session. And when you're ready to begin, we'll start the clock.
All right. Good morning, everyone. My name is Eva Gail Rising, and this is Darian Rising, as you all heard. I'm from United Aircraft Technologies, where we're creating a new class of clamp for electrical wiring that is modernizing the way maintenance is done and is helping aid in the Army modernization priorities. It is designed to reduce weight, improve safety, and simplify maintenance through the use of augmented reality and artificial intelligence. Apologies. There we go. So a little refresher about who we are and what we're doing. First and foremost, we're addressing the weight problem currently in aircraft. Aircrafts are capped with weight. And you have between 1,000 clamps in a Black Hawk helicopter, all the way to 15,000 to 20,000 clamps on a larger commercial or larger fixed-wing aircraft. And they're made out of metal, where the cushioning around it wears off, exposing the metal, which then cuts into the insulation and has led to electrical shorts, which have caused crashes, emergency landings, as you can tell from that picture of what's left of that wire bundle. And in regards to maintenance, these clamps are very difficult to install. They require between 4 to 7 additional pieces of hardware. I know there's some aviators here, so you may have seen them around. And they're very difficult to reach in certain areas. And when you have to do this setup, if you drop something, everything needs to stop. You need to find where it is because of FOD. And when you have to monitor the electrical system, currently there's no method that can really help you localize and pre-diagnose faults within the wire. And you have between 2 miles to 45 miles of wiring in some aircrafts. So, in reality, we want to take these clamps, which are outdated from the 1940s or even earlier, as you can tell from this very sped up video that requires a lot of additional tools and time, to this, a thermoplastic clamp that acts like a buckle. It is non-corrosive, non-conductive, eliminating the risk of electrical shorts, and it has sensing mechanism inside of it, and it hosts it, that can measure amperage leaks, electromagnetic interferences, changes in temperature, humidity, radiation, sonic weapons, among others. The reason for sonic and radiation is because it also has applications in fiber optics, where those are the things that will disrupt the wave through the fiber optics. So how do we address the modernization priorities? So first and foremost, for the future of vertical lift, we expand space capability. We can take off or up to 600 pounds of the aircraft. And that helps put new technology into these new aircraft. I mean, you're hearing from amazing technology here, and you're going to continue hearing it through the next couple of days. And out there, all this technology available, but you cannot simply put them in because the aircrafts are too heavy already. Or you can extract and soldier out of a combat zone. Additionally, we can increase the range of the aircraft, helping our military have further reach in areas where it matters the most. We can increase up to or extend 4 miles of extra range. And we can accelerate mission readiness, making sure your aircrafts are ready when they need to be ready, because we make aircraft maintenance 5 times faster. So for a proof of concept, when you last saw us, we had the design of our base model, and we had the research done behind the sensing capabilities. And we kind of knew where we're going with the augmented reality application. After we were given this amazing opportunity, we set out to improve the weight. Our previous weight was around 14 grams, which was lighter, but we wanted to improve upon that. We wanted to create the sensor. We wanted to create the humidity and temperature sensors. We wanted to set up a monitoring platform, help build communication throughout it so it is encrypted and easy to do, and build our augmented reality platform. So, what have we done since last you saw us at X-Tech Search? First and foremost, we were able to expand our engineering team. We have a 5-member engineering team, and thanks to the great opportunity, we now have a retired Boeing engineer and a GE aviation engineer helping us lead the effort forward. We have final design on our base model, which is the white one you see right there that I'm holding. This is the base model. We have the final design on this, which is the molds are going to be made for injection molding and should undergo military specification testing next year. And we also set up the blue disc that you see around it, the sensor, that it's working, it is reading, it is communicating with our platform. We also set up mass manufacturing, set up our mass manufacturer that will help us access with clean rooms and as well as help us set up all the manufacturing process so we're ready to go. And thanks, you have no idea when I say this, thanks to the opportunities we had at AUSA, we were able to meet i3 Core and who help us set up the augmented reality platform, which I'll speak with them a little bit later on. They're in the audience today here supporting us. And set up our monitoring platform as well. Click, click. It's all right, I'll move forward. It's the internet. There we go. So, what about commercial applications? What opportunities did we have? Well, after AUSA, we made connections in Boston, and now are being supported by BAE Systems in their augmented reality efforts through their HoloLens capabilities for submarines, aircraft carriers, as well as aviation. We have received interest from Embraer, who we recently got bought out by Boeing, to have our system within their aircraft and for pilot programs as well. The Air Force also is supporting us in development, where we are now commercializing one of their technology, and we have their support, where this technology, where we're not capable before, is allowing us to not only measure amperage leaks, but be able to tell you which wire within that specific bundle that leak is coming from. We are also supported by Lockheed Martin. They have helped us ever since we were an awardee from Sikorsky Innovations and have helped us continue in the support of development of this technology. DEFCON, of course, we met up with them again in Aberdeen Proving Grounds, and where we're looking at collaborating in the radiation and sonic sensors. And i3, as I mentioned before, i3 Core, they're here supporting us today. They are an amazing development firm for the Department of Defense, are great at augmented reality, and have helped us set up this piece for you today, and will continue working with us as we continue to hone in the augmented reality interface. So let us really show you what we mean. Darren here is going to show you through our TV right here, our monitoring system, where you can see, he lost his voice, he wanted to talk, but he lost his voice today. As you can see here, we're receiving data from our sensor, and this data is encrypted in 30-bit. And when you go in on the user interface, you can go in, for example, when you're doing maintenance, each group is set up to work on a certain number of aircrafts. You can go through them, and then once you go in, you can read specifically each sensor, read what's going on. In this case, this is real data that we have, the temperature spike, and where you can see the performance of each sensor, which system, what is actually happening more frequently within the aircraft. And this can be done by the mechanic, or it can be done by the QA manager as well. Now, when they scan the aircraft for augmented reality, here we have a video, but here I have my iPad, the application, which I will demonstrate for you. Hopefully it connects. It's still showing the little video. But regardless, I'll do it here. For augmented reality, as you can see here, apologies. Here we have the aircraft, which you can track, you can rotate, you can increase the visibility of the entire electrical system or reduce it if you want. And you can also, when you scan, it's reading the clamps. And as it's reading the clamps, it's gathering all this data. And if there's a problem within the augmented reality system, which is also applicable in HoloLens, where the mechanics can actually go there and be troubleshooted, it can tell you, hey, there's a problem here. You can see which system it is. You can go in and see the system in high fidelity. Go target where the aircraft clamp is causing. We can select the affected wire. And then when it selects the affected wire, it will tell you how much is the temperature, what's the sensor that's been triggered, by how much temperature. You can scroll through the different clamps. It will tell you by how much, what's causing it, and then we continue building where the aircraft mechanic or electrician can actually go through the HoloLens, go where it is, and be guided through the troubleshooting process, helping reduce human error. So instead of us just showing you or talking about it, we have set up here a display for you. We have stages. A stage is for you can showcase the weight savings capability of our clamp, where we reduce it from 14 grams down to a small, lighter size. Here we have a mock-up of the wire bundle, where we can showcase how easy it is to for our clamp to be installed. And then I have the augmented reality system here, which we can also look at how it actually works. So I would like to invite my judges to come and take a look at it for themselves. So first and foremost, for weight savings, here we have, yes, thank you. Here we have the full assembly of a clamp. And here I'm not including spacer and including all the other materials, just this. With this, it is 26 grams. With ours, which is included, the bracket is included in, just zeroing just in case, it's only 8 grams. And while this is our 3D printed model, it still has the same density as our selected material. And if you want to know which material it is, I can tell you post-presentation. Now, Darren here, he was an aircraft mechanic for the U.S. Army and Navy for over 12 years. And he's going to showcase what it's like putting that clamp together. They're made out of steel, so they're very hard to maneuver. And he's doing a butterfly install where you have to connect all of them, make sure you connect it through the both holes, put the spacer in, put a washer, put a nut. And keep in mind, here we have so comfortable space. You know, we don't have to worry about anything, but in the aircraft, you have to reach around behind the airframe to tighten that knot, which is very difficult. And you still require a lot of additional tools to do so. But with ours, it acts like a buckle. It comes and it disassembles. You put it around, and it snaps into place. And they interconnect with each other to do the same installation with the butterfly install that he just did. And with here, we also have our augmented reality. You can hold it, play with it, if you whatever you would like to do. It will put it on a plane right here, but for the augmented reality, it will track the aircraft, and you'll be able to look at it. So you can go to the system, you can see the hydraulics. Sorry, apologies. Oh, here it is. You can locate and see the hydraulics, and see the entire system in high fidelity. And you can see where all of our clamps are located and being able to go in through as we move along. Of course, once it's implemented the HoloLens, this is an option because we all interact with technology in our own unique way. This is an option for them, but they can also go in straight in here and go straight to it, helping eliminate all the time that they have to be up in these aircraft because they have to climb it, literally, to get up there. This helps them avoid that problem. And I will more freely let you play with it post-presentation. Thank you so much. So, essentially, we've done great strides since we started, because we started with an idea and some research. And this is where we at and where we continue to keep moving forward. And we have the team to get us there. So the person I told you briefly, I want to expand a little bit more about it, is Darian. As I said, he was a U.S. aircraft mechanic for the Navy and the Army for over 12 years. He developed repetitive strain injuries where he lost his job, his house, everything. And he used his GI Bill, went back to school, and became an engineer and created the solution that we are creating today. I built the business before from Puerto Rico. I grew it where it got acquired by a mother organization. And after hearing his story, how passionate he is, I just jumped in and we moved forward. We have a team of engineers leading on the headway, where we are a veteran-owned, minority-owned business. The internet keeps popping up, it keeps disconnecting. But regardless, we also have support from the officials. Michael Trascos, who's the chairman of the SAE wiring subcommittee, the people that determine the military standards for wiring, supports our technology and believes it could be the next military standards. He does testing, military specifications testing for this, and he has looked at our technology development and has helped us get where we are today. So, if we were to be named the winners of the XTech search, we have some plans for the use of funds for the development of our technology, which, as you can see, we worked really hard on. We want to complete our sensor network, which we're already underway. We want to get our final mechanical clamp military specifications tested, because we already have pre-orders, we already have interest on this model. By commercializing this, it will keep the company going and keep self-funding so we can continue providing for the military, because we're not only a military provider, but we can also have commercial applications to be always here for the military when you need us. We also want to complete our platform, as well as the augmented reality applications, where we can use more of our artificial intelligence to go through the predictive maintenance process and use the Air Force technology for it. And we want to improve the augmented reality user interface, so it is more in-depth and it's easier to interact, among other things. So first and foremost, I want to thank XTech Search. You guys are changing the way that small businesses can interact with the military and helping us really go where we always dream to be. So thank you for your time, thank you for the audience for listening to us, and thank you for our supporters, I3 Corps, and I'll take your questions.
Can you talk a little bit more about the sensor technology and any issues with the aircraft with all these emitting sensors? Okay.
So we are right now doing commercialization with the AFRL, the Air Force Research Lab. We are licensing their technology to be able to isolate a single wire that is faulty. The technology that we have is proprietary information, but we'll be happy to talk to you about it after the presentation, how it works, how it isolates the wire. These are actually, they harvest the energy from the vibration of the aircraft to communicate, so they're wireless, and they don't require any battery.
So it also works, and it is an ask and receive basis. So you will have to ask for it, and it will send the information, and it will be able to differentiate between each other, so we don't interrupt anything that's going on. Yes.
So based upon the vibration, right, to power it, would that mean if your aircraft was, in storage for a while, then they would not be active, these sensors?
We also have RFID, so you can actually retrieve the data when it's stopped.
And we have ambient sensors, which is why we were able to power our sensor here, even though there's no vibration.
A few questions. So I see how this would be very beneficial in like a new aircraft because you already have to bundle the cables up. And how long do you think that it would take to reclamp an existing aircraft? Because there's many of old aircraft within
Yes.
the military, so that's a. And then how many clamps per wire bundle? Is it every meter, every something to that?
Yes.
There are wire standards. Every 6 inches, you may have a clamp all the way to 2 feet. Depends on the size of the aircraft. They're very easy to retrofit because we are using the same number 10 hole that exists in the aircraft. So all you have to do is just take out the old clamp and replace it with our new. And our new has a bracket, tiny bracket that uses an aluminum military standard rivet that is a permanent structure to the aircraft, so you never have to worry about taking that out. You only replace the clamp.
So there's no alterations whatsoever.
And then thinking from my expertise is communication, so thinking from the information that clamp is pulling, who monitors it, who keeps it, who can view it, and then is there a real-time feedback? So while in air, could a pilot know if something was going wrong with the aircraft, that they could land the aircraft, something to that nature?
Yes, only authorized personnel from the military will be able to scan the aircraft once it lands. They have a login account that is, of course, authentic, and it uses a platform, Army platform works. CAC card, I'm sorry, I'm losing my voice because I have a cold. I really apologize. Sorry, your next question. Yes, it has the capability to alert a pilot if something is has a discrepancy, a pretty bad discrepancy.
So it can alert the pilot to be able to land the aircraft when needed.
Are there smaller diameters? I mean, a different size clamp for different applications. Any problem getting all of the sensors in the smallest diameter clamp?
There are 66 sizes currently in the metal clamp. We got them down to 13 sizes, and there's no problem putting the sensors in because currently we have this sensor, but we're going towards nano. And once we get it to nano, it can fit the smaller size bundles.
Yes, we vary the diameter of the grip on the inside to accommodate all the different sizes of wire bundles, and we color code them as well.
You didn't talk at all about the physical integrity and over temperature too, at different hot and cold temperatures, and whether they're just strong enough. Can you address that?
Yes, of course.
Do you mean the electronic sensing equipment be able to withstand high temperatures?
And the physical integrity of the brackets.
Oh, okay, no. Okay, the material that we selected to do the clamp injection molding process is already military standard, and it already passed all the testing and toxicity, and it can withstand very high levels of temperature.
So it can withstand over 300, and then we have some other things that we add to it that are in the nanomaterial world that can increase that temperature up above 800.
Yes, for aerospace applications.
So along those lines, how long does it take to fabricate like a single bracket? Is it a pretty fast process?
Yeah.
You mean the injection molding process?
Yes.
Yes, it's pretty much a mold, and then it uses a thermoplastic, and then it injects the thermoplastic pretty much in a melted state until it hardens and comes out as a solid.
So the manufacturer that we have can produce over 1 million units per month.
That's for the plastic for the clamp itself.
Yes.
What about integrating the sensor?
So for the sensor, we are currently establishing a manufacturer that to help us along with that because it is going towards nano. So it is very fast to do so to produce nano chips in larger scales. But that question, it will be a little more difficult for me to answer right now until I go through that process, which is why.
What about the current sensor technology?
So the current sensor technology is very simple to do. Is pretty much off the shelf, so it wouldn't hardly take any time at all to set it up.
For the current technology, it requires an electronic housing external to the clamp because it's bulkier. So going towards nano, it simplifies the process, and we're able to embed it inside the actual clamp and keep maintaining the weight savings.
And the manufacturer that we work for with knows the embedding of the electronics, so they will do it in-house and keep up with the bulk. Go ahead.
How do you synchronize? You see, you can get into a point where you can identify which wire in a bundle is faulty. How do you do the synchronization process to identify which wires are providing what type of information?
You want to know about the process of isolating the wire? That's the proprietary, but I'll be happy to talk about and how we do this after the presentation.
Generically describe the modality.
Just in a really generic way, describe what kind of sensing modality it is.
You mean for like our amperage sensor?
The wire isolation.
Oh.
Okay.
What can you say?
All right. We're using AFRL technology that is able to swipe the entire bundle and by comparison be able to identify which one is the one that has the discrepancy.
Depends on the field
Right.
emitting. Any other questions? Well, thank you so much for your time. I really appreciate it.